Hi there, folks, and welcome to Down to Earth. My name is Eric Edelman, and I'm your host for this evening. So, according to the music you may have heard playing up to this segment here, you might know what we're going to be talking about today, which doesn't quite match the picture on the screen, but that's on purpose. We're going to tell you a little bit about that today. This is the day that's after the 4th of July, which important holiday for Americans, but also Juno's arrival at Jupiter. And in case any of you were wondering, we left the show last night. We had that live show about Juno's arrival at Jupiter. We left that in sort of a certain state of uncertainty, knowing that it was entering the right sort of orbital motions, but not sure if it was going to finish out through that successfully. We were optimistic, and our optimism was not to be betrayed because, yes, it turns out that a little bit before midnight Eastern time, NASA got communications back saying that, hey, Juno was in orbit, everything went fine, things went wonderfully. A real testament to the ingenuity of those engineers working on that team, people that have spent years, maybe decades of their life really preparing for this, and it seems like it's paid off so far. But really, this is just the beginning. We have to wait until mid-October for the actual science to start. It's in an orbit around Jupiter, but it's going to be nudged a little bit closer over a few months. But this is a major, smoothly completed step in the right direction. Let's just put it that way. And we're on track. So kudos to NASA for this incredible accomplishment. We're expecting a lot out of this. And that's what we're seeing here on the screen, is the concept art of Juno arriving at Jupiter here. And so this means that we currently have one man-made craft orbiting Jupiter. Just one. Just one. That's it. Nothing else. The last spacecraft to even get anywhere near the planet was New Horizons, when it used the planet for a gravitational assist. Like, remember in the last show, just yesterday, we were talking about how Juno used Earth as a gravitational assist, using its gravity to speed up. That's what New Horizons did when it flew right by Jupiter in 2007. And it is really hard to get a spacecraft orbiting this distant monolith of a planet. It's a huge thing, it's far away, so we don't see a lot of things getting too close to it. And so conditions are just pretty tough. Honestly, there's a huge amount of gravity, the monstrous magnetic field, just really not hospitable conditions for scientific study. So some of the planets out there in our solar system are a little bit easier to reach. And so what is the planet, actually, if we were going to ask the question, that has the most stuff presently orbiting around it? And this is leaving out Earth, of course. We know a little bit about our own planet. We don't need to send spacecraft out to that as much because they're already there. But that answer would actually be Mars. So currently, there are a lot of different spacecraft that are going around Mars. And so we're seeing a video here of a lot of things that populate Mars. There are currently 7 different spacecraft on or around Mars. There's 5 orbiters, there's 2 rovers, and these are all in total coming from 3 different countries or 3 different space organizations around our planet. And so Mars is very, very crowded. There's a lot of stuff going on there. And today we're going to be talking about what's going on here on Mars, why there's such a big party here. And we'll be comparing the science that's going to be starting on Jupiter with the work that's going on Mars. And so what is the difference between exploring this distant gas giant Jupiter versus our closer terrestrial neighbor, Mars? So here on Down to Earth, we're going to be looking into all this in order to sate our curiosity. So first, let's just bring in the live images here, though. We're looking actually live at Jupiter from, I believe, the Canary Islands that's actually the Chile scopes that we're looking at Jupiter with there. That's live image of Jupiter, and I'm sure the Juno can see it a lot closer up. But we here at a distance, this is what we get, and it's really an incredible view in itself. We actually see those bands along the surface of Jupiter's atmosphere. And so we see that detail, and we're going to see more of the science emerging from this atmosphere over the next couple of months. And we also have some recent images taken of Mars with the Canary Islands telescopes. And so, yeah, we have those telescopes in both hemispheres. Quite a bit of fun. And we see that sort of the distinctive reddish tinge, that tinge of war, of violence that we heard in the music building up to this show. That's actually the movement in the Planet Suite about Mars. That's the music that you heard right in the beginning of this segment. And so these are the planets that we're working with here. So what's going on Mars? So we know what's going around Jupiter, but let's meet the family that's currently on Mars. So I'm going to go through a quick rundown of the current Mars missions, only the ones that are still active, or else we'd be here all night, to be honest. So then after that, we're going to start digging a little deeper into certain areas surrounding the science of that versus the science of Jupiter. So we're going to go in chronological order here. And first, we have to start with 2001 Mars Odyssey. That's the first spacecraft that we have, which was launched in 2001. There it is, 2001 Mars Odyssey. Very particular pun, but I don't believe it has found any of those humming slabs orbiting Mars or whatever they were in that movie. I'm still not quite sure to this day. But the NASA orbiter here has a spectrometer and a thermal imager on board. So it's looking for things like water and also studying the radiation levels on Mars, which is great in terms of considering future manned missions or colonies on Mars. So seeing if we can deal with the conditions that are present there on that planet. So we have to know how much radiation we're dealing with if we ever want to send people over there. And then after 2001 Mars Space Odyssey, then we have Mars Express from the European Space Agency. And this one was launched in 2003, still going around. So we have these really long missions that are going around Mars too. And this one reached Mars in the same year that it was launched, 2003 and 2003. So this was actually at a time when Earth and Mars, they were the closest that they had been in about 60,000 years, right around this year. And so one of the reasons it was called Express is because we were able to do a bit of an express delivery to the Mars planet because it was launched at such a convenient time. And so this orbiter has been mapping the surface of the planet, giving us a little bit of the topography, so to speak, and studying the motions of the atmosphere. And then next after Mars Express, we have good old Opportunity from NASA. And this is a rover, so switching gears here, or a land vehicle on the surface of Mars. And this landed in the beginning of 2004 and has been wandering around the Martian surface ever since. And so this little guy really is the little rover that could. I'm telling you, it has lasted right about 12 years longer than was expected with the initial plan. It was actually, in the beginning, expected to just function for about 90 days. 90 days versus 12 years, like that's a long expansion. I don't know what Opportunity is eating over there, but it's sure working for it. And so what it's been doing, the little rover over there, it's been studying craters, been looking for meteorites. So the cool thing about that is, how we have, meteors that streak across our sky, little bits of, asteroids and comets that end up on our planet. Same thing going on over at Mars. So these exometeorites that haven't thrown themselves onto our planet, that have thrown themselves onto another planet, seeing maybe the differences there. And oh yeah, here is a conception of the Opportunity rover, just hanging out on Mars, exploring what it has to do. And so yeah, it's just giving us a better idea of what's on the Martian surface. And so next we have on the list another NASA mission. So a lot of NASA stuff. We've had NASA so far and also the European Space Agency. Those are the couple so far that we've gotten to. And so the next one is the Mars Reconnaissance Orbiter, or the MRO for short, which has been orbiting the red planet since about 2006. So still very long missions that have been taking place here. And this orbiter has been studying different landforms on Mars, checking out potential future landing sites. So again, going back to that possibility of colonization, what sort of things do we need to keep in mind if we want to send people there? Well, it'd be great to figure out where to land them. Also, potential help for future rovers that could be coming around as well. And so also observing the Martian weather patterns, that's a great thing. And is a great communication hub. It's sending back a lot of data. It's also helping other missions that are coming toward the planet. It's a great communications hub is what it is. And so then after the MRO, we have something that has been a lot in pop culture recently. We have Curiosity, that rover there. And so here's actually an artist's conception of Curiosity landing on Mars. And so that was quite a fun contraption that we had going on there. And Curiosity has been hanging around since 2012 on Mars, so just about 4 years. And this NASA mission has shared a lot of overlap with both its orbiting and its roving predecessors. It looks into habitability, it looks into sort of what's going on there, and into weather, and generally what is going on the Martian surface. And it's actually, this is the most recent rover that's been on Mars, but it'd be cool here to sort of look into an evolution of what the rovers we've sent. So we've sent a rover called Spirit, we've sent a rover called Opportunity and Curiosity, and we actually have an image. Oh, there they are, of the size comparisons between the rovers. So on the far right, we have Curiosity, and then we have Opportunity, and I believe Spirit is that smallest one, sort of down by the bottom left. And so there's a big evolution of what we've been able to send up there over just the course of pretty much a decade. And it'll be exciting to see the next things that we bring up to that planet as well. And so then the next thing on the list is not a rover. We got another orbiter, and this one is MOM, or the Mars Orbiter Mission. You can celebrate it on Mother's Day too if you'd like, but I don't think it'd quite work out too well for you. And so the Mars Orbiter Mission is great because it's the first interplanetary mission sent out by the Indian Space Research Organization, or the ISRO. And so this makes it the third space agency to have sent a mission to Mars. We don't have any active Russian missions right now, but Russia has been to Mars. So that makes up the fourth. And so the main goal of this mission was actually to say, we can do it. We can send something here to show off sort of the capabilities that they have here at the Indian Space Research Organization. And also, on another side, to sort of look into what's been going on in the surface geology and the Martian atmosphere. So they're bringing in some of that science as well. And so consider this the start of a bright spacefaring future for the ISRO. We're looking forward to seeing what comes out of them next. But then, last on our spacecraft list is MAVEN. MAVEN came there very recently. It's another NASA orbiter, and that arrived in 2014. So it's just been there for a couple years now. And the acronym MAVEN actually tells us about what it does. It's the Mars Atmosphere and Volatile Evolution Mission. So evolution, it uses both the E at the beginning and the N at the end to make the MAVEN. So, you know, what can you do? You want to make sure that it's a sweet sounding acronym so people remember it. And MAVEN's pretty fun. And so what it will be doing is we're trying to figure out where the Martian atmosphere and water went over the course of the planet's history. And so we know that there's a lot less atmosphere on our planet than there used to be. So what happened to it? Why is it not there? And sort of looking at the interactions between solar wind and different things like that. And so that's our family right here that we have on Mars. The 7 active missions, the 2 rovers and the 5 orbiters, all from those 3 different space agencies. So really a global cooperative effort. And it's outnumbering Jupiter's robots from 7 to 1. It's just a much bigger crowd that we have on Mars. And so like we talked about earlier, Jupiter is just, for a lot of reasons, it's more difficult. It's harder to reach, it's more distant, and it's also harder to stay around. Juno is actually expected to be able to do science around the planet for about 2 years. And so then on the other hand, we have things like 2001 Mars Odyssey, which has been going on for about a decade and a half now. So a longer period of time. It's just, it's easier to stay in orbit, easier to stay active around Mars. And so what does this mean for the science that we do on Jupiter versus Mars? And we'll just, to be honest, we know a lot more about Mars. We're starting from a more solid foundation about our Mars understanding than we are presently with Jupiter. For example, when we think about Mars's internal composition, we know a lot about what's going on there. We know it's iron and nickel for the most part with a little bit of sulfur. And we also know in terms of the surface of Mars, we have rovers that have actually drilled into the surface of the Mars soil. And they drill in there, they get little drill holes, and then they actually can shoot lasers into that little drill hole that they've made to figure out the composition of that soil, of what's going on there. And so actually here now we're seeing a video of Curiosity as it's drilling down into that soil there. So we're able to really intimately interact with the surface of this planet much better than we can when it comes to Jupiter. And Jupiter's just a lot more violent. And so, yeah, oh, here's a great image here. So that's sort of the end result of the drilling. And you see the large hole there is the drilling that Curiosity did. And then those little sort of dots you see at the sort of the top left, that's the laser that sort of shot into the drill debris and got out some information about what is the composition of that stuff that it drilled out. So a lot of really direct science is being able to be made when it comes to Mars. And so then on the other hand, we have Jupiter, which we know a lot less about. So we know a lot about the composition of the core of Mars. We don't even know when it comes to Jupiter. Here's our live image coming in from Chile of Jupiter here. And we don't know if Jupiter does have a solid core or not. That's one of the goals of the Juno mission, is to figure out whether there is a solid core deep down there or whether it is just a gaseous ball. And then when it comes to the atmosphere, the Martian atmosphere, even though Jupiter, we see so much of that atmosphere, we know a lot more about the Martian atmosphere. We know about the atmospheric loss. We know it's about 96% carbon dioxide. We know there's trace amounts of argon and nitrogen, oxygen, and water. So there's big details that we know. And here are some of the latest images we've got from the Canary Islands as well from Mars. That's currently set in our view now, but some of the most recent images that we got with our Global Telescope network. And so on the other hand, we have Jupiter, where one of the missions that, or one of the goals of the mission here for Juno is to figure out more about the composition of Jupiter's atmosphere, to figure out how much oxygen there is versus hydrogen, to figure out how much water there is in the atmosphere. And so to get to the places that we already know about with Mars, to take that step forward and yeah, just take us a little bit further. And so these are actually my personal thoughts on the matter as we're going forward here. I think that the science that we do on Mars is more of an exploration of ourselves, whereas with Jupiter, it's more of an exploration of our environment and what potentials lie beyond us and the human experience. For example, a lot of things we're studying right now on Mars are going to benefit us in terms of future occupation, of us traveling to Mars, in terms of learning about the radiation, in terms of learning about the topography of the planet, where we can land, what the atmosphere is going to be like, and just how hospitable or not it could be to humans who potentially go there to do science or go there to colonize. And so yeah, we've done a lot of comparisons to what we have here on Earth. There's a great comparison that was made of the Earth soil versus the Martian soil, or the rock formations there as well. There's a lot of things going on. And then with Jupiter as well, oh yeah, here's the comparison image. So we see a lot of similarities to ourselves when we look at Mars versus when we look at Earth. And then on the other hand, we have Jupiter, which when some of the questions we're trying to answer, things like, does Jupiter have a solid core? Does Jupiter have the amount of water that we think it does? All of these are in a lot of ways tied into sort of the very beginnings of our solar system's formation. They will tell us a lot of answers about where we as an entire solar system, more so than a human race, have come from. For example, solid core, the question of that. We'll talk about how Jupiter itself has formed, whether it formed by just a collapsing of gas or whether it did form when there was a core and then a lot of gas came around it. That will tell us a little bit about how terrestrial planets or rocky planets might have formed in our solar system, because if Jupiter has that rocky core, it's sort of related in some ways to that terrestrial planet formation. And then on the other side, thinking about how much water there might be in the atmosphere of Jupiter, that's going to tell us where Jupiter formed in this gaseous cloud, this swimming disk of material that didn't make our stars and our planets. Depending on that amount of water, it could have formed where we see it now in our solar system, or it could have formed in a more distant, further out position and then migrated inward because of different solar system events that occurred over the course of billions of years. And so, again, a lot of the things we're trying to learn about Jupiter is a big story of our solar system itself. And a lot of things we're trying to learn about Mars are more of, where can we go from here? Can we step foot on this planet, and what would that mean? And this, again, this is just my personal opinion on the subject, but in many ways, when I look up at Jupiter, I see the past and I see us gleaning answers about where we've come from and how this planet in particular has shaped our solar system. And then when I look at Mars, I see the future. I see the potential and the question of where can we go as a species. And it's amazing to see them juxtaposed here on the screen here with Jupiter and Mars. We see them both, but they mean so many different things, and they mean a lot of different things to me. And so when we see these two telescopes here in the Slooh, from the Slooh Observatory, Mars from the Canary Islands, and Jupiter from Chile, we see them in our skies. But these scientific missions that are starting to tell us a whole lot about ourselves are just taking us a little bit further into worlds beyond our human experience. And so this universe, it's really a fun place. And I'm so happy that, in some ways I can explore that here with you. And this is just our solar system. I mean, the future of humanity is bright. Who knows where we will go within our galaxy or the many galaxies out there. And so it's really to end this show here today. I wanted to ask, what about you? What do you think of these missions that we're doing here on both Jupiter and on Mars too? Are there parts of these planets do you think we should be focusing more on, we should be studying more of? Are you satisfied with the direction we're taking our scientific studies right now? I mean, there's so much to learn, and maybe we're glossing over some things we shouldn't be, or maybe we're on the right track. But I'd love to hear from you about it. We have a chat box. If you're watching on slooh.com, you'll either see it to the right of this show or below it, depending on your browser. But yes, we'd love to hear what you're thinking. We always love to make this a conversation here at Slooh that everybody in the community can take part of. And so, yeah, let us know. Are we on the right track, or where should we be going? Let us know what you think. But yes, that has been our show here tonight, talking about Mars and Jupiter and the potential we have as humans for learning about our solar system and where we might be able to go in the future. So thank you very much for joining me here tonight. And of course, I will be back next week, same time, same place, for another Down to Earth, as always, on Slooh.com.